Good morning. Right. We've got a little bit left to finish up in 10.9. That's all we'll do for today. And I think that should be no problem. We'll probably finish up even early today. That'll leave us tomorrow and Friday to go through the exam review. I'm not going to go through every single question, obviously, because like I said, there's like 32 or 33 of those questions, I think. So I'm going to try to focus on the ones that I think you'll need for the actual final exam. So showing up tomorrow and Friday, or at least going back and watching the video, will definitely be beneficial. So make sure you take a look at that if you can't make it tomorrow and Friday. Don't forget that your last test number 5, is due Friday by midnight. I have graded test 4, so those grades are in Blackboard if you haven't seen that already. So you can take a look at what you got there and look at the feedback that I gave you. And then if you have not already, be sure that you go into the form that I put in the announcements a couple days ago and schedule a time for your final exam. Okay, so I've gotten most people at this point, but if you are planning to take the final and have not yet signed up for a time, please make sure you go ahead and do that, because again, otherwise on Friday, if I haven't gotten a response from you, then I have to assume that you're not planning to take the final, and then I'll just withdraw you from the course before you actually receive an F instead. Okay. Again, over the weekend, once I've kind of gotten all the other grades in there, if you're questioning whether or not you want to take the final or just withdraw, please do email me and we can have that discussion. But go ahead, even if you're unsure at this point, at least sign up for a time so that I have an exam ready to go for you. And then if you decide, after I grade test 5, well, it's probably not worth it, then I can always take you off the list. Okay, but at least sign up for a time if you're thinking about taking the final, and then we can, take that back if you decide after test 5 that you don't want to. Okay. Any questions about anything at this point? All right. So let's go ahead and finish up 10.9 then. All right, so yesterday we started looking at graphing inequalities, right? And we looked at a circle and where we would shade that. We looked at a line and where we would shade that. And so what we're going to look at now is a system of inequalities where we actually take 2 of these inequalities, we put them onto the same graph, and we look at the actual solution to that system. Okay, because remember, the solution to a system is all the points that make both of those, in this case, inequalities true. All right, so our first step in doing that is we're going to graph each inequality, right? And that's what we looked at last time, was graphing inequalities. So we know how to do step 1. Then what it says is we're going to graph the solution of the system. Now, what we mean by that is we're going to shade the region where they overlap. So we're going to have to graph both of them on the same graph or separately. Think about where those graphs would overlap each other, and that part of the graph where they overlap is going to be the solution to our system. And then the last step here is what's called the vertices. Okay, so we're going to find those points of intersection of the 2 graphs, and we'll label those as vertices of our system of inequalities. The real big part of this is actually finding that overlapping region because the points there are going to be the solution to our system. Okay, so let's take a look at this system here. Okay, now what you'll notice, these are actually the same 2 inequalities that we graphed yesterday. So we graphed them individually yesterday. Now we're going to think of them as a system and think about what that solution would look like. So let's just start here with that top inequality. And go ahead and remind me, what did that inequality look like? It was a circle, right? Now, what did we know about that circle? Okay, the radius is 5. Good. So I'm going to go ahead and do 1, 2, 3, 4, 5 in all directions here. these points here would be on my circle. Good. Now, what do we know about this? Good. It's going to be dashed, right? And what tells us that it's going to be dashed? Okay. It's just a less than symbol. There is no equal to on this. So that right there tells us that our circle needs to be dashed. And so I'm going to go ahead and create my circle. Make sure that I'm making it dashed. And again, especially with circles, just do your best, right? Because not easy to make that a nice, pretty circle, but do make sure it's a dashed line at least. Okay. Now, what else did we have to do with that circle now? Okay, good. We picked a test point to determine where we were going to shade. And so in this case, I think we chose 0, 0, right? The origin's always a nice one if you can use it. So as long as it's a point that's not on the circle, when we plugged in 0, 0, did that make a true inequality or a false inequality? It was true, right? And so since 0, 0 made that inequality true, that told us we were going to shade everything inside of our circle this time, right? So everything in here got shaded in. So that was the solution, right? Or just the inequality itself, right? All those points are part of that inequality, everything that's in the shaded region. Now, this time, so we have a system of inequalities. We're going to take that second one and we're going to graph it on the same graph that we just had there. I'm going to switch my color here. So hopefully we can see the difference in these. All right, so what did that second inequality look like? Okay, it was a line, right? And what did we say about that line? What were the things we found out about it? Okay, had a negative slope, right? What else do we know? Okay, it goes through 0, 5. So let's double check that. So when I solve this, if I do that, I'm going to move the x over. I'm going to divide by 2. So that's going to give me y is greater than or equal to, this should have been negative 1/2 x, and then plus 5 over 2, right? Good. And so 5/2 is actually where it's going to cross the y-axis. So that's 2.5. So we go up to 2.5. I'm going to put a point there. Our slope was 1 over 2, so we go down 1 over 2. It was a solid line, good, right? So we know in this case, because of the equal to this time, this line right here is to be solid. So I'm going to make my solid line here. Make it as accurate as I can. Not going to be perfect, but do my best. Okay, so there's the line. Right, and then just like before, the last step was we had to pick that test point to figure out where we were going to shade this one. Where did we end up shading this line? Up, right? Okay, so we found out when we plugged in 0, 0, it gave us a false statement this time. So we wanted to shade away from 0, 0. So we ended up shading everything above the line. So that's what that part looked like. So that's step 1, right? So we're going to graph both of our inequalities and just see what they actually look like. Now, step 2 tells us that we want to only focus on the overlap of those two graphs now. Okay, now I'm just going to kind of sketch this one out. I'm not going to try to be real picky with the points and everything. So I know I had my dash circle. I know I had my line here. Now, where is the overlapping region in this case? Kind of describe it to me. Okay, where do these two graphs overlap? Okay, good. So inside the circle and above the line, right? It's everywhere that that blue and red overlap each other. Okay, so that's the only part of our graph that we care about now is where those two things overlap. So again, I'm just going to kind of sketch this out. So I've got my dashed circle, and I've got my, sorry, this is 1, 2, 3, 4, 5. So my line here. Like this. Okay, and now all I'm going to graph for my final answer in this case is going to be the overlapping region, which is everything inside that circle and above the line. So it's just that little piece of the circle there. So that's step 2, right? So that's actually the graph of the solution to these inequalities, because now it's only those points that are in that shaded region in that second graph that are going to be true for both of our inequalities. Any questions on that? Okay, so just make sure on the actual test, when I say graph it, don't give me that first graph because it doesn't show me that you actually understand the solution. Make sure that you're giving me that second graph because that tells me that you understand the solution is only the overlapping region, right? So we only want that part of our graph shaded now. Now, once we got that, what was step 3? Vertices, right? And by vertices, we just mean where do these two things intersect each other? So it looks like I've got a point down here somewhere and a point up here somewhere. And again, this is a rough sketch, right? So it's not going to be exact, but at least we know in general, okay, we should have 2 points where these graphs intersect. That's what we're trying to find now. How can we find those 2 vertices for this system of inequalities now? Okay, you could, right? So we could graph these, right? We could use the calculator to actually find the points of intersection. You could also graph it in Desmos and just see where they overlap. The only other way that you could do this algebraically this time would be by substitution, because notice here we have an x squared and a y squared in the first one, an x and a y in the second one. So you can't use elimination here. So you either got to do substitution or you could graph, right? So let's just look at the graph and we'll find the points of intersection that way, because I'm fine with that even on the test. As long as you have a way to actually find those. We have x squared plus y squared. I'm just going to graph it as an equation so we can see where they intersect now. X plus 2y equals 5. Let me share this with you. So there's the graph. And it's pretty close to what we got there, right? We've got 1 point up in the second quadrant where they intersect, and then it looks like the other point might even be right on the x-axis. I'm just going to click on those points, find those points of intersection there. And so in this case, my vertices, we're going to have -3, 4 as one of our vertices, and the other vertex is going to be at 5, 0. Okay. And again, however you find those is fine, right? If you want to put it in your calculator, find the points of intersection, use Desmos to find it. Or again, if you want to use substitution, you can actually do it that way too to find those points of intersection. All right, so again, on the actual test, when I get a problem like this, what I'm looking for is, do you have the graph? Do you have it sketched correctly, right? So make sure your lines are dashed or solid the way they're supposed to be. Do you actually have the correct shaded region, right? And only the overlapping part. And then did you find the vertices, okay, which I've got listed down here now. So those are kind of the things I'm looking for on that question from the test. Any questions there? Anybody need more time on that one now? And the one on the test does at least give you a coordinate grid, so you can do that however you need to, and then just sketch your graph over there on that coordinate grid that's given. All right. Then we're going to skip this next one. I do want to look at this one, though. Okay, so we're going to graph the solution set of the system of inequality. And so we've got two different systems here, but I want you to notice they're very, very similar. The only difference between the two is our first one there is greater than or equal to, and our other one here is less than or equal to. And so I want to show you in this case how big of a difference just one little thing like that can make, because otherwise these systems are identical to each other. We are going to use Desmos to do this. So if you want to put it in Desmos yourself, I will share this also. All right, so I'll come back to this, okay, just in case you wanted to copy down those, but again, they're in the slide, so you don't really need to. Let's take a look at the graph. There we go. Okay, so in Desmos, you can actually put these in as inequalities, right? So you just, if you want a greater than or equal to, just press the greater than and then the equal to right after it, and it'll automatically make it a greater than or equal to. So just know that you can do that, and that'll make it a solid line. If you judge it as greater than, it will make it dashed also. All right, so there's our inequalities, right, all graphed together. So now if we're looking for the actual solution to that system, what are we trying to find? Okay, where they all overlap, right? So we want the overlap of every single one of those inequalities, and there are 5 of them this time. Okay, so what I'm going to do is I'm going to go one by one so we can kind of see where this region is, because right now it might be difficult to kind of see exactly where they're all overlapping. So I'm going to turn off all of these and just focus on the first one. So the first inequality there, it's everything that's above that green line, right? So we know we're at least restricted there. Now when I turn on this one here, now that purple line is also above the line. Okay, so now I'm only looking at that region that's above both, right? And so you can kind of see they intersect there at 2, 2. And so that's kind of the point where it changes direction, but we're looking at that upper right quadrant right now. Now when I turn on that black line, okay, kind of same thing. We're still up in that upper right-hand quadrant, but now we have this other point of intersection at 4, 1, okay, where it also changes direction. So now we've got that region there. We're a little bit more restricted, but we're still up in the upper right-hand corner. And now the last two are just that x is greater than 0 and y, greater than or equal to 0, and y is greater than or equal to 0. What that does is it forces us to completely be in the first quadrant, right? Because that means we're to the right of the y-axis and above the x-axis. So now we know we're restricted by the 2 axes, and we're in that upper right-hand quadrant. So our final solution to this one is that dark blue region in the upper right-hand corner, okay? So any questions on that part? Okay, now in this case, right, because I don't have my notes projected right now, we're only looking at the graph. What we would say about that region is that it's unbounded, okay? And the reason we call it unbounded is because it's going to go all the way to infinity, right? So if you notice here, the y values are going towards positive infinity, the x values are going out to the right towards positive infinity. So this region is unbounded because it's not restricted, right? It's not constrained by the lines themselves. It's going to continue on forever and ever and ever. Okay, so that's what we call an unbounded region. Now what I want to do is I want to look at that second set of inequalities, the second system, where the only thing that changed was that one sign got switched to a less than or equal to. So I'm going to take this first inequality and I'm going to make it less than or equal to instead. So what does that change about the graph now, right? So that was the green line. So where is that green line shaded now? Down, right below the line. Okay, so now if I'm only looking at the overlapping region of all of these inequalities, so the other ones didn't change, right? They were all still kind of up and to the right, but now that one green line we're only shading below. So can anybody see where the overlapping region is now? Or give me a shape of what that overlapping region looks like. Yeah, it's a little tiny triangle in the middle there, right? So we have to be below the green line, but we're still above all the other lines. We have to be in the first quadrant because of the last two inequalities. So it's only that little triangle in the middle there. All right, so what we would say about that region now is that it's bounded. And the reason that one is bounded is because it's not going out to infinity or negative infinity, right? We are constrained to that one little shape there because we have the three lines that all intersect each other, okay, and form this little region there. So that's what we call a bounded region. And again, all I changed was that one inequality symbol, and it makes that big of a difference in what the solution to that system looks like. Okay, so just keep that in mind, especially when you're having to move things around, maybe solve for y to put it in your calculator. Forgetting to switch an inequality symbol, like if you divide by negative, can make a huge difference in your final answer. Okay, so just be very, very careful when you're putting these things in there to make sure that you get the correct final answer. But again, the main thing I wanted to point out there was what an unbounded region looks like versus what a bounded region looks like. Any questions on that one? All right. And again, there's those terms, right? So this first system here, we call it unbounded, and then this second system here, we would call it bounded. All right. Let's give in that one last example, okay? So I think everything's fitting on the screen. Yeah. All right. So a lot of stuff here, right? So we'll go to another slide to actually work this one out, but let's kind of read through what we know. So a factory produces 2 agricultural pesticides, and we're going to call those A and B. For every barrel of pesticide A, the factory emits 0.25 kilograms of carbon monoxide and 0.0 kilograms of sulfur dioxide. For every barrel of pesticide B, it emits 0.5 kilograms of carbon monoxide, 0.20 kilograms of sulfur dioxide. Pollution laws restrict the factory's output of carbon monoxide to a maximum of 75 kilograms per day, the output of sulfur dioxide to a maximum of 90 kilograms per day. So we need to set up a system that's going to describe how many barrels of each pesticide they can produce while still meeting these government regulations. Okay, that's the first step, and then we'll try to answer the questions below based on the system that we create. So read through that stuff, right? Again, just like when we did systems of equations, the first thing you're going to want to do is figure out what are we looking for, what's the variable going to be, so we can define those variables, and then we can start setting up our inequalities from that. So what do you think our variables are going to need to be this time? Okay, so you want to let it be A and B. So now we need to define those variables. So what does A represent here? Okay, so you could think of it as like your X and your Y if you were graphing it, right? But in this case, I just want to know definition-wise, right, from the context of the word problem, what are we letting A represent? Okay, so it is pesticide A, but it's specifically what about pesticide A? Think about what those units would be for A. Okay, so it's actually not going to be kilograms because the kilograms in this case represent an amount of carbon monoxide or an amount of sulfur dioxide, right? So what does the A actually represent and what are those units going to be? Okay, so those are the other things that we're going to have to use to write our inequality, but we can't use those as units, right? Because those are actually, in this case, gases that we're trying to limit our production of. So read what it says. We're going to find a system of inequalities that describes what? Barrels, right? So in this case, when we find these variables, we're going to represent the number of barrels of pesticide A, and B is going to represent a number of barrels of pesticide B. So again, keep that in mind. Always think about your units first because that'll really help you to see inequalities. So now we know that A actually represents the number of barrels of that pesticide. B represents the number of barrels of that pesticide. Now, let me make a new slide here so we have a blank one that we can work with. All right, so I'm going to leave this here and we'll kind of go back and forth between the two slides so we can actually write out what we want here. Okay, so if we want to set up an inequality using A and B and using all that other information, can you think of one inequality that we could set up this time? So one hint that I'll give you is think about the thing that you're trying to restrict, right? Because that'll help you to figure out what the inequality might look like. All right, so Kenneth's got 0.25A plus 0.50B has to be less than or equal to 75. You got it. Okay, so there's one of our inequalities. So we've got 0.25A plus 0.50B less than or equal to 75. Now let's walk through why that is what it is, right? So if we go back, we know that each barrel of pesticide A is going to produce 0.25 kilograms of carbon monoxide. And we also know that barrel B is going to produce 0.50 kilograms of carbon monoxide. But we also know that we don't want to produce any more than 75 kilograms of that carbon monoxide. So what I'm going to do is I'm going to say, well, every barrel A is going to produce 0.25 kilograms. So there's the 0.25A. Every barrel B is going to produce 0.5 kilograms. So there's the 0.50B. And putting that carbon monoxide together now, I can't have any more than 75 kilograms of carbon monoxide total. So my total needs to be less than or equal to 75 kilograms. So any questions on how we got that inequality? All right. So now think about what the other inequality might look like using other information that we've got here. All right, so we got 0.60A, there's 0.60 kilograms sulfur dioxide, and then 0.20B, there's the 0.20 kilograms sulfur dioxide, and we know we want to have less than or equal to 90 kilograms of sulfur dioxide total, and so that is correct. Right? So our second inequality this time is going to be 0.60A plus 0.20B has to be less than or equal to 90. And sorry, I use lowercase letters there, right? Either way is fine. Any questions on how we got that inequality now? All right, now here's my question to you. Do we have any other restrictions other than just those two things? Right, so we know we have to restrict our carbon monoxide. We know we have to restrict our sulfur dioxide. But is there any other restriction that may not even be written here that we have to consider for barrels of pesticide A and barrels of pesticide B? Okay. Tell me this. Can you have a negative number of barrels? No, right? Okay, so what we want to do in this case is we want to make sure, because A represents barrels and B represents barrels, and we know they can't be negative, I'm also going to say that A needs to be greater than or equal to 0, and B also needs to be greater than or equal to 0. I'm restricting myself to things that only make sense in the context of the problem, because I know I need to get positive results out of this, right? So again, there may be times where there's things that aren't even written there, but because of the context of the problem, we just know those things to be true. And so now this is going to be our system this time, and now we can graph it, right? So again, I'm going to use Desmos to do that. I'm just going to use X's and Y's instead of A's and B's. If you wanted to use your calculator to do this, then you'd have to actually switch it to X's and Y's and then solve for Y to be able to put it in there just to kind of see what it looks like. So let me share this graph now. So that's what it looks like right now, right? Just with everything turned on. Now, in this case, what do you think we might need to do? Okay, so we could, right? So we could look at these individually, right? So I'm just going to turn everything off except the first one. Well, that's what that graph looks. So what do you think we might need to do now? Zoom out, right? So if you notice here, right, we're seeing the entire graph that I've got in the window. It's all shaded. Okay, so I'm going to zoom out now, see if I can actually find, oh, there we go, right? So in this case, because our numbers, we have 75 and 9 here, okay, we know these numbers are going to be, not really large, but larger than just negative 10 to 10. And so we're going to have to zoom out to actually see that line. Right, so there's the first one. And now let's start turning on the other ones. I'm going to turn that one on, okay, and that looks pretty appropriate for that window. If you wanted to, right, you could, move it a little bit. We can at least see where those things overlap each other now, right, because both of those are going to be below the line. So now we're looking at that. But if we also want to be greater than or equal to 0 for the x and greater than or equal to 0 for the y, right, now we're restricted to the first quadrant, but also below the other two lines. So now we can see there's this region right here in the first quadrant, okay, and it's a quadrilateral, right? We got 4 sides to that region. So we have a bounded region. Those are the points that satisfy this inequality. That represents the number of barrels that we can actually produce this time, okay? So any questions on that part? Okay. So here's my question to you, right? So I'm going to leave the graph up there and I'm going to ask the questions that were at the bottom of that slide. So it says, would it be legal for the factory to produce 100 barrels of A and 80 barrels of B? So could we produce 100 barrels of A and 80 barrels of B? Okay, so Asbel says yes. So why can we? All right, Sarah says no. All right, so what are we looking for to determine if this is yes or no? Right, so if I want to know, can I produce 100 barrels of A and 80 barrels of B, what am I looking at? Look at the shaded region, right, just the overlapping part, and we want to know, is 100 of A and 80 of B in that overlapping region? Because if it is, then we know that that's acceptable, meet our government regulations. Okay? So now 100 A, right, would be the X value. And then if we look at 80 for B, that would be the Y value. So we're basically saying, would point 180 be in that quadrilateral region that we talked about as being feasible? And in this case, if you go over 100 and up 80, that's still inside that overlapping region. So in this case, yes, it would be legal to produce 100 barrels of A and 80 barrels of B. Again, I'm going to show you real quick. If I plot the point 180, that point lies right there. That's in our shaded region, our overlapping region of all 4 of these. And so that's why we know that's a yes. Any questions there? Okay. So now the second question is, would it be legal for the factory to produce 60 barrels of A and 160 barrels of B? Okay, so German says no. This one's a little harder to see, right, just based on the scale that's there. But let me plot the point, because this time we would want 60 A and 160 of B. And you can see now that green point, that actually falls outside of that bounded region that is the quadrilateral. And so since it's outside of that region, we would have to say, no, it is not legal, right? That would put us over our limits for our emissions now. Questions on that one now? And so just so you know, right, this is the type of problem that companies and factories do all the time, right? Because they know there's government regulations, they know how much emissions they're producing with different things that they have to produce. And so they have to decide, okay, what can we actually produce? How can we maximize profit, right? That's always their big question. And so they have to think, well, how many barrels of each of these things do we want to produce so that we're maximizing our profit, but also staying within regulations? Any questions at all on anything from that now? All right. That's all I've got. So that's where we'll stop. Again, tomorrow we will start the exam review. If you have a chance to take a look at it beforehand, that way you kind of know where your questions are going to be. That would be great. But again, we'll go through again the ones that I think are going to be on the actual final. I'm going to try to focus on those tomorrow and Friday because we definitely won't be able to get through all 30 some of them. Okay. But otherwise, have a good afternoon, and I will see you tomorrow.